Hello, welcome to today's talk. Today I'm going to be covering some of the ways we handle a lot of our data at Ubisoft. I've created a couple HDAs to try and solve some of our pains. The talk will also be covering some of the troubles and some of the things I wish people told me along the way, but it was really just a learning journey for me and I wanted to show you some of that. The final will be investigation into PDG, or procedural dependency graph, and looking at some of the ways we are doing prop destruction or investigating how we can start working on automating all of our prop destruction pipeline. So today's schedule, I'll be covering who am I, our data archiving pipeline, some of the Python pains I've gone through, learning Python of course, creating a custom log tool, and then finally a prop destruction workflow with PDG. So who am I? I'm Thomas Tobin. I teach at the Game Art Institute online, and there'll be a Houdini course coming out soon. I work at Ubisoft working on procedural tools and some of the ways to optimize artist pipelines. And finally, I used to intern at Side Effects, and I created game pipelines or investigating different ways to work with Houdini in games. If you want to contact me, that's my email. So let's get started. A quick intro into HDAs. An HDA is a Houdini digital asset. Think of it as an encapsulation of a tool. For example, the first step is make a bowl. Then the HDA would be, can I turn this bowl into a cup? And you just have a couple parameters that allow you to change the bowl into a cup. The next step is you take the HDA and you link it to the next asset. So if we create a fry simulation, we can just scatter the fries, drop them into the bowl that you just previously created, and then finally take your RBD sim and simulate, for example, gravy on top. So we don't necessarily use it to create a procedural fry bowl, but let's cover some of the ways that you actually use these HDAs inside of games. At Ubisoft, we have a tool called Portfolio. Now, Portfolio allows us to share assets or any finished objects over any production of all of our games. So if you want to share a 3D model, a texture, material, animations, anything, you can upload your final asset onto the site, and you say these are the legal restrictions, these are your sharing restrictions, and from there you can then share with anyone within Ubisoft. This allows us to create more efficiently our games that we're working on. However, this can be a huge pain because sometimes it's asked at the end of the project, sometimes it's asked during, but hey, could you upload the assets you've been working on Portfolio? I'll cover some of the pains of why this is actually a painful process. Because if you're working on a game that's been in production, for example, Rainbow Six Siege, which is 6 years right now, finding a source asset from the original Siege or something you worked on right when you started can be very difficult. I know since I started at Ubisoft 1 year ago, I've changed computer 3 times. So if I was asked to find a file that was, I don't know, from my first week here, that would probably not be possible. So the examples today I'm going to be showing are in Anvil. So that's the icon on the left. And we want to really take this as a tool that's project agnostic. I wanted to create tool sets that were not reliant on a single project and made sure that if you use Houdini as the core or as the fundamental base connection, you can go from any pipeline that we have or any tool or DCC into Houdini and output into whatever you want. So Houdini really was the connection here. Now, we have a 17-year-long license, so hopefully my tools don't die until then. So the main challenge was we need to create an asset bank of props. Now for an asset bank, you need textures, you need the FBX with all of your textures assigned. You also need source renders, so you need a turnaround of that actual prop. And so you have to collect all of this data, making sure it's all the latest, and hopefully have a source file too. Now, just remember, it may come off as this is a little bit of a lazy task and an artist should just have to do this. But when we walk through these steps, you'll find out there are a lot of small steps that you might accidentally mess up if you can't find the original file. And so we wanted to optimize or almost automate a lot of these steps and make it as easy as possible for an artist to extract data from whatever engine they're with. So today's examples will be with Rainbow Six Siege, and it will be on the map of Bank. For example, if you grab this APC Truck, the first thing you want to say is, I want all of the APC Truck. So you have to box select the APC Truck. However, you've just accidentally selected the manhole and a puddle down below. But I don't know if anyone can actually tell me if I've selected the chairs inside, or the headlights, or even the glass. And so you may go through an entire extraction process, simply missing those objects and then having to go back. So this APC truck actually took 3 artists about 3 hours to extract, because there were a lot of back and forth, and you'll find there's a lot of fiddly steps that were made like human mistakes along the way. Then we can use 3ds Max, and we have a tool called MaxHammer. MaxHammer allows us to extract assets from Anvil and port them into 3ds Max. You'll see, however, only the diffuse is assigned. So you have to go to the folder that contains that diffuse. However, you get a huge folder of all your previously extracted textures all in the same location. So trying to find this single file is really difficult in itself. You don't know what that texture is called, and you have to try and locate it. So you go back to Anvil, and you have a button that says Pick Textures. This allows you on each material to click Pick Texture. You click on the material, and it hopefully brings you to the textures. So now you can see that inside of Anvil we have all of our textures that you just picked, and luckily we have a Photoshop file. However, now you have to go through this Photoshop file, batch export your diffuse, your normal, your metallic, your glossiness, any type of data you have on it, and go back to 3ds Max and manually assign every single one. So we're done, and you set up that material. However, that was one material of many for this APC truck. This simple process of grabbing textures, reassigning them, and making sure you're selecting the exact same texture and you're not making any mistakes along the way, because if you do, while you render or if you actually upload this to Portfolio, someone that downloads this data later on, it may not match, and they're actually not having a useful mesh that they can work off of, and you're making it more time consuming for them. The final step is renders. If we just do a simple turnaround in Anvil, you get your full PBR renders of in-game. However, this has a couple problems, because as you actually extract the asset, this is what the pure data looks like. The same APC truck is actually white, and that is because the diffuse is actually white on these, and an artist inside of Anvil has done the multiplication of another channel. So they've taken the white texture and multiplied it inside with a vertex color of gray, for example, or black. For each and every shader variant, you could have an artist doing any tweaks in engine, and that data is actually not on the original source data. So it's all lost information that isn't reflected. So if you show them this mesh, and you show them that it's black, and they end up downloading it and it's white and looks completely different, there's going to be a problem there with reusing that asset. Finally, this is a view of every single FBX in the map of bank. So you have to do that simple process over every single one of these FBXs over, for example, 13 maps. So there has to be an alternative, we thought, and maybe there is, but Ubisoft is such a large company that we just haven't found one yet. And so this was kind of the process we thought of, trying to solve that and trying to make this process as easy as possible. The first thing I wanted to look at was extraction. Now, extraction, as I mentioned before, was difficult because we needed to ensure that you grabbed the exact objects and made sure that you actually had the source file. So we work with a team at Ubisoft called Helix. Now, Helix is an internal team that allows them to extract, or they can work with any engine within Ubisoft that they're integrated with and extract the data or use it in different ways. For example, marketing content or anything else like that. So we asked them, hey, could you extract bank, for example? And this view, again, is every single FBX inside of bank. Now, you also get the entire map dumped as textures and 3 JSONs. Now, we use these 3 JSONs to basically use them as Lego instructions to reconstruct all of that map data. For example, geometry says this is where these props are located, so we can exactly know where all the instances are in the map. Lod 0 says, hey, I am this prop, this is where my LODs are located, and this is my setup on this specific prop. Finally, materials explains this is all the parameters, all the changes an artist has made in engine, and this is exactly how you can reconstruct the anvil shader, for example. So that led us to the next step. We have all of the raw data on disk now. We don't have to go through the extraction process. We just need to fake all of this extraction. For example, if you start with this APC truck, the first step I wanted to fix was the actual selection process. When I select this APC truck, for example, I didn't want to have to box select, hopefully grab everything, because I know that they follow the naming convention. So when I clicked just on the tire and the car body, and I hit Control C, luckily for me, but of course by design, we got these two strings. When I saw this, I saw Gen Exterior Vehicle, Car APC Base, and Car APC Tire. This was super useful for me because I just had to strip away any of the naming convention and find Car APC Base, Car APC Tire. Now, the first part of my tool was Fuzzy Wuzzy. I just had to take Car APC, run this through Fuzzy Wuzzy, find any potential matches, and bring them into Houdini. This basically took out the entire process of selecting Car APC, I don't know, window, Car APC, headlights, Car APC, anything. And it just allowed me to just search Car APC and find 50% of the matches, 60%, and try and find most of them using a fuzzy search. Now, this is a common Python library you can find here. So the first step was generating geo. I needed to find out how can I extract anything from my clipboard. And then, from there, I just have to read the JSON and reconstruct it. So the library I chose was C-types. Now, this is a common code library you can find online. You can just go to Stack Overflow. And the simple code block, which I use all the time now, simply just grabs whatever is in the user's clipboard, closes it, so I don't have to worry about any of that code. And from there, I can then just say, search that specific string. So in this case, I just use Car APC Base from that, and from there, I get all of the instances of Car APC Base. However, you can see with Fuzzy Wuzzy, because the brigades or the actual barricades here have something to do with Car APC in their naming scheme, maybe it's close enough, maybe it's just within the limit, I actually get them. So there's a reason I have all the instances. I could have just said, I want this specific instance that you've selected. However, if you look at some of the props we'll look at later on, each artist has placed them differently, and you can choose an even better layout of the prop. So having all the instances inside of Houdini allows me to choose the best instance, or the best setup of each one I want, and so it doesn't matter that I have some extra props in the selection process here. The next function I needed to work on was gather and delete. I just had to say, you select inside of Houdini, I want this and this prop, and then I can just delete and clean out everything else. The next step was centering out the object. This was interesting because a lot of the objects use instances. For example, the tires are a single FBX that are instance over all of the tire positions. So I needed to take the entire object matrix and ensure that the entire bounding box and everything could be centered out and put in the center of 0, 0. Otherwise, it would just be floating in the scene randomly and wouldn't be at 0, 0 in the scene. And the final step was save and collate. I needed to collect all the textures, everything, all the data from the JSONs, match it all within the Houdini instances, and put that together. So let's see what that looked like. The first step was generate geo. So I have everything copied. I just generate, straight away I have the meshes in Houdini. There's no delay now, because I already have all of the raw data on disk. From there, I just say I just want this truck, and save and collate, and I'm done. I actually have a saving check there, and then finally I have save and collate, and we're done here. This renders this image. Now, inside of Houdini, we're using Mantra to render this image. But we run into a couple problems here. The main problem was, the shaders do not know if they're a transparent shader or what type of object they are. And so an alpha decal may be rendered as translucent, not translucent, or a cutout shader. And so this was a problem because if I do not know what type of shader I am, it can't render it specifically how it should be rendered. The next problem was time. Now, Mantra is used for film for very high quality renders. However, for us, we needed a very quick and iterative workflow. For example, this single image took 10 minutes to render, and there's quite a few problems here that could be resolved just by fixing their transparency or their shading. However, I wanted 5 to 10 seconds of rendering per image. From there, the outcome of the tool, what I just ran through, we get all of the textures that you manually had to find before. You get the FBX and a new source file. Now, the new source file allows anyone to go back to the scene. They can open it up. They have all their exporters still there. You can see on the left-hand side, we have our material networks with every texture assigned. And finally, you have all your FBXs in the scene. Now, the Filmbox FBX is important here because we wanted to run a custom outporter script. We needed to ensure that all the instances were still respected and embed textures could be turned on, so we just had to write a custom exporter for that. From there, the geometries, this is inside of Maya, for example. You can see all of the textures are still assigned, and we can now filter by instances on the image on the right. So car PC base gets a new parent, and underneath we get every single instance of that tire. This allowed us to use FBX instancing and also keep the hierarchy of what the mesh should be. The next step was some of the Python pains or learning things along the way. Now, I'm not a programmer by nature, but this was the learning journey that I took to figure out some of these things and find out how can I solve these problems as I'm learning Python and trying to integrate them into my tools. So we'll be covering a couple of my learnings and a couple bug fixings which I know about now, but would really have been nice if someone told me before I started or if I had taken a programming class, of course. Now, the first problem was my PyPanel worked once but not twice. The main problem I found out was I needed to use classes and getters and setters. When I ran the tool once, I wasn't sure if on the second time I was running I was resetting all of my variables. So if I used a single class and stored all of my parameters or all of my variables inside of there, on running the tool twice, I could just delete the class instance and re-instance it in and having a new fresh instance of parameters or variables to work off of. The next was getters and setters. I wanted to use classes specifically so I could ensure the data coming in was exactly what I was looking for. For example, if you're looking for a texture, I could ensure that the texture coming in was a target. If it wasn't, return me an error. Or if we, for example, at the top of the image on the right, created mat list, I needed to ensure that any data in there was actually a material. So I could do any of those checks before I even save it in and overwrite a variable. And this ensured that I didn't have any problems along the way. This was really interesting. If any of you have been working in Python in Houdini, you'll notice sometimes the Python panel or the Python debug console will print to and just stop. For example, if you print to 4, if we go print 1, print 2, print 3, sometimes print 4 will never appear. There'll be no error, there'll be nothing that's showing that the actual function has failed, and sometimes it will even continue, just missing print 4. So a programmer on our team said, hey, you should just, a very easy way to fix this is use try and except to loops. Just put, say, your main function inside the try block, and then if it fails or if it gets an exception, import traceback and print that exception. So now straight away I could have the exact point of failure always guaranteed. If my code ever failed in one of those blocks, as I was debugging or working on the tool, I could have that traceback error inside of the Python. And this really fixed a lot of the problems of why is my tool not working, where is it failing, and from there I could easily fix it. The next step was FBX exporter. When I first ran the tool, we were only able to export diffuse from the FBX ROP. This was a big problem because only exporting the diffuse, I still have all the channels not assigned. So what I had to do was nest them into a big string. Just there you can see the pound sign. Now, the pound sign allowed me to put in all of my strings into a really long string. So for example, I strip away the entire base folder because I know they're all going to be in the same location. I just have my diffuse map name, I have my spec, my normal, and so on, all in a big string, and just use the Python split function and pull them apart later. So in any DCC I wanted to read from afterwards, I just knew the exact order and pulled them apart. Now, it would have been better if I had exported out a JSON or something and just read back, but at the time I just wanted a quick and dirty way to export the data and make sure all of it was there. The next was saving checks. I wanted to ensure that any artist or anyone using my tools along the way were not working on an empty file. You'll find that if you're running Python scripts or something, they might go directly into your C folder if they're not saved, or they may go into a random folder overwriting data you don't know. So I always ensure that if the title of the project or the HIP file is named untitled, then I display the message file must be saved and don't allow the user to proceed further. The final is when I'm actually copying files over or making sure that all the data is being transferred, I force the user to save. And this allows me to ensure that the source file before they export is always latest, and they can go back to that source file if something goes wrong, make their changes, and then re-export. The next was hard path references. Now if you're a programmer, you'll already know what the problem is here. When I printed var, I expected to see the exact string above. However, I was getting map exports. And this is because I was using something I didn't know about at the time, but escape symbols. So using /\n basically ended the string and escaped. So I needed to declare somehow that this string should not be escaped or don't listen to it. So you could use double slashes to signify a single. However, when I wanted to just import a string, I didn't want to have to parse through my entire strings. And a quick and dirty fix was putting R in front of your string. This just declares the string as a raw string and allows you to just move on. And for there, I can then change that later on as a parameter that a user puts in. So if they do Control-C on a file, I can just take that exact string. But if I'm just hard code testing, I wanted to be able to just take it, use it, no changes being made. So the putting in the R reference allowed me to really easily and quickly fix this error. The final thing I needed to fix was rendering. I wanted to ensure that my rendering time was super fast and the easiest for the artist. I didn't want them to have to do their own custom render setup or anything like that. And I also wanted to ensure that the render actually viewed what the data looked like. So the ending of this tool looks like this. Say we want a desk. The first step is save it in a folder. I then have to go to Anvil. I found this desk that I like. I hit Control-C, and I go back to Houdini and I hit Generate. From there, I have every instances of all the props in the scene. I've just matched the desk inside the Houdini viewport, so the cameras line up. From there, I can say I just want this desk. However, I know that there's a lot more instances of these setups, so I want to find a more ideal prop setup and something that represents the final outcome of the props I want. So I just found one. I hit gather and delete. I clean up about 200 objects. From there, the final step is Blender save and render. So I needed to create a live link of sorts to send that data to Blender, render it all out, and bring it back into Houdini, and making sure this is a super quick process. So right now we're rendering out, I believe they're 4K images, and within 5 seconds, we have our complete turnaround done of a full PBR render of the actual raw data. So what just happens there? Inside of Houdini, we are able to load in those external images of the Blender renders, have all of their parameters or anything that's displayed on the top left of the image baked in, and then have every angle viewed. So this allows you inside Houdini to ensure that the objects that you just exported are actually what you're giving the user in the end. For example, if I selected the desk and the only thing being rendered is a phone, maybe that export process had a problem and it didn't actually display an error. So this allows you to really quickly define, hey, there's no problems here, we're all good, move forward. So the main thing I had to fix inside Blender was I needed to recreate a version of the Anvil shader. So we just read through the GSL code of the Anvil shader, and then from there we were just able to say this is a rough approximation of the PBR shader, and we just had to pass in every parameter from the diffuse, the spec, whatever from each FBX, and tie them into their point in the node graph. So this gave us a turnaround image of all of the props, making sure that they're set up correctly, exactly what the diffuses actually look like, and in their proper locations. The final step was using PDG, and if you have a bunch of different objects inside, for example, an Excel graph, you can just say, I want this object as this name, and so on. You can then run every single object you've just exported through PDG, or the procedural dependency graph, and automate the render process. So we can just send all of our renders and let them run all at the same time. And then just contact sheet them together so you can have a nice view of these are all the assets you just exported. From there, we can just connect to Portfolio and batch upload your assets straight on if you approve them. So the next step I wanted to look at was whole map transfer. This was a fun thing I wanted to look at because I wanted a quick way, I have all the instances, a quick way of porting into another DCC or software. So the first step was, of course, make an HDA, or make it work once first and then HDA it, and then we can see from there. So the first step was we need to actually create a point cloud. So the first step was read the log.json and read the collision JSON. So I know where all of the objects are in the scene, and I'll show you what that visually looks like in a moment. The next was, thankfully, the Anvil matrix and the translation matched exactly to Houdini, so I didn't have to do any corrections there to fix that. From there, we just set up our collisions, and we can run through any cleanup, and this would be any HDAs along the way. So when you instance an entire map, you could say clean up normals, or clean away small objects, or any type of naming convention cleanup all at once inside the Houdini tool. And that was the benefit of doing inside of Houdini, was anything we wanted to do afterwards or through this entire extraction process, we can just drop in modules of HDAs to fix things and iteratively change stuff along the way. The next step was collision. We needed to know that this object has collision, first of all, and then where's the collision located? Our collision FBXs were not inside or matching the same of their source FBX. So what I mean by this is, if you have one cube, for example, the cube at each point does not know if it has a collision object associated. So we needed to check, do you have a collision object first of all? Then we needed to create the collision geo instance, or the attribute, and this allowed us then to specify this is where the actual FBX is located. Now, this didn't previously exist, but thanks to CLAN and side effects, we were able to really quickly have an attribute that is custom, that any Houdini engine instance could read and say, this is where your collision is located, and load those two FBXs as a single mesh. So in the end, you get a ton of points for a single map. You just have to declare, this is where the JSON is located, this is where your collision is located, and then we can look at objects. So at each point, they know I am a desk, I am a chair, I am a car, I am a wall. I know its exact rotation or orientation, and do I have collision or not, and if I do have collision, where is my collision mesh actually located? And that's an external reference again. From there, we just load in this HDA we just created into Houdini Engine, and straight away we can have the meshes inside of, for example, 3ds Max in 5 to 10 minutes. So from Anvil, we just load in 3ds Max, we have all of our data in one folder, and we can hit reload data and port from Anvil to 3ds Max or Maya or any other DCC in one click. All we have to say is that this is where the data is located, and you have everything in whatever tool you want. From there, we needed to clean up normals. So on the collisions, I wanted to be able to just view the collision mesh and have proper shading. So you can see on the left, it took about 3 to 5 seconds to clean up the normals on 8,000 objects. However, in 3ds Max, the exact same Python script took 11 to 12 minutes. So again, this iteration time and trying to speed up the workflow was really helped by going inside Houdini. you can see the image on the bottom is the representation of this is a single map. So using Houdini, we were able to create an HDA, for example, this normal cleanup, batch export all of our props, and then recreate them inside their maps and do any type of HDA fixes after the fact. The final step I wanted to look at was LOD tooling. We needed a custom LOD tool that kind of solved some of the problems of going to very low poly counts. But why? Because Houdini, or the Side Effects Labs, has its own LOD toolset. And so a lot of this that I'm going to be showing today is directly taken from the Labs toolset. This really saved me because I didn't have to recreate these exact setups, or for example, the presets here, I took exactly the mesh decimation, and this tool allowed me just to take their nodes and use them in different ways to create a very similar LOD tool but with a different outcome. So using the Labs toolset, or the LOD tool that they've created, the two blocks of nodes on the left that I've outlined in red, I've taken directly. Now, the first one allowed me to simply orient the text above the name, and then the second one, I believe, spaced them out and allowed me to have them all viewed by the user or put them back together. So I could have all of my LODs displayed in a line or overlapped and have their poly count listed above. This was something I knew I would have to do, but I didn't have to put in the time to figure it out because it already existed for me. The next thing I took was remove small parts. This was something essential I knew I needed, and I wanted to ensure that as an artist is creating a LOD, for example, if we look at my water bottle, if I don't need this little screw, then I can just strip that away and clean that up after. And so having this remove small parts part of the LOD tool allowed you to go much more aggressive with your deletion. So a lot of the actual UI or the setup of this LOD tool I took directly and took a lot of their nodes just to recreate the functionality. From there, we just even take their Python module. I wanted the exact same preset system that they have, so I could just go through their code, take it, and use it as well. Now, a lot of the nodes I use day to day, I just wanted to highlight some of these because they're super useful and they save a lot of time because you don't have to go through the same process. The main one is Quick Material. This allows me just to instance this in and drag in any type of diffuse and metallic normal and straight away have all my textures inside the viewport. The next I took from was actually inside of the LOD tool, and that was Remove Inside Faces. This allowed me to strip away, as you get farther and farther away from the LOD, strip away anything inside of the drawers or anything like that. The next is Axes Align. I wanted to ensure that any type of LODs we were working on were always centered. So I could take the entire bounding box and then just use the Axes Align, bring that in, and center out the mesh. The next was Merge Small Islands. I wanted to make sure that if I had any UVs or anything, as we were decimating down, I could just batch them together and make sure that the very far away LODs had just grouped together their UVs in that sense. So if you had a very small object, it could potentially be brought into another island. Sometimes this isn't possible because they're just not connected, but if they are connected, it just allows me to do quick cleanups, or actually say, if we look at my phone, the pen could potentially be a very small island, and I could just overlay the same on top of the mesh and ensure that the small island was matching the texture. So one, you do texture matching, and then two, you do your UV matching, and ensuring that if it's small enough, can you force it onto another matching texture. So it's a hand in hand. The next was Calculate Occlusion. This was important because for my LODs, I wanted to define if they have a certain occlusion setup, if they have a certain curvature, or if they have a certain poly count, run a specific type of poly reduction on them. So it can choose the best optimized way per mesh using a lot of these different things. And again, these are things I just didn't have to recreate by scratch. Finally, if we wanted to bake out a final combined texture set or an atlas of all the textures, we can just use the Maps Baker. Extract file name I've just started recently using, but it allows me just to very quickly extract into an attribute the file name. And multi-file, of course, you can just define, for example, this desk, if it's multiple FBXs, bring them all into the multi-file and have one single file node. So let's end up looking of what we actually created. The start of the mesh, let's look at this desk again. Lot 0 is 5600 polygons. Using the labs toolset, we could bring it down to 1700. However, you can see there's a couple normal shading issues down below on the bottom of the chair. We've destroyed the little wheels, and the monitors are just starting to get a little too flat for my liking. So what I worked on was a very similar setup using almost all of the same nodes, just in a different way, and we don't have the same shading issue. We have better looking wheels and just a bit similar poly count. However, again, it's not perfect. You can see the keyboard has some issues and has to be cleaned up after. Next is when we go even more aggressive. Now this is a problem I've seen on every tool I've tested, is going very low poly counts. Decimating these meshes is very difficult, and you need very specific setups for different low poly counts. So when we've set now to 872 polygons, you can see it's completely destroyed the chair. We've destroyed the desk at this point. The computer on the left is broken. So a lot of these things I need to fix. So with the tool that I created, again, it goes through a very specific setup. So if it has this type of AO or this type of curvature, this poly count, do this specific type of poly reduction. So let's look at the comparison within actual different softwares. Within Ubisoft, we use SimplyGone a lot. However, if you take a staircase, for example, and you bring it in and you set it to a very low poly count, it will completely destroy the mesh. If we say, again, this is the source asset on the left, which is 252 polygons, and set it to the exact same poly count as SimplyGone, it's closer, but we still have holes, and I don't know if you can see that or not. So the system I worked on was, if there's a specific type of angle, make sure you always ensure that that angle stays, and I do a rough approximation. I say, give me roughly 60, instead of exact 60, give me around that. And it actually goes lower and just strips away all of the bevels, it polymerges, it just fixes anything without any custom nodes, and gives me the best result from the source asset. The next was UV comparison. I needed to ensure that my UVs weren't stretching. If you have stretched UVs, you'll see that the ground texture starts to warp and stretch. So preventing your UVs from stretching will prevent your textures from looking weird or altering along the way. So, for example, if we start with a trash bag, you can see from log 1 to log 2 on the top left of the trash bin that we're actually getting a lot of strong stretching just here. And so this stretching is not ideal, because as you go between more detailed meshes, or you go between the APC, for example, as you go very low poly counts, those verts are there trying to stretch their UVs as much as possible. So the system I worked on just simply reprojects each time, ensuring that the most ideal UVs are set up. So you get a very similar setup along the way, and we can actually ensure that the UVs never distort if possible. The final setup is, say we take a drawer cabinet. If I want to, again, delete by size of object, now I actually can. SimplyGone does not support this functionality, and so using Houdini or taking the direct setup from the log tool, we can just clean out the handles, the decals, anything on top of these server cabinets, for example, and just clean away smaller and smaller meshes, or as they progressively get bigger in this case. So the process I created wanted to be as least painful as possible. So if you take an asset from your desktop, again, it's the same C-types library, you directly create the instance inside of Houdini for the artist. They don't have to worry about learning the UI, it's just there for them, it's ready to go. There I can just say delete some small objects, force the root tolerance, and then I can just, as it's multi-parmed, just increase the amount of LODs I want. And this allows me to really quickly iterate and create more and more LODs, just doing custom setups along the way. From there I can say, if this is a certain type of object, save this as a preset or default. And then if we match the same naming convention, for example, exterior vehicle car, if we're importing a matching asset that's exterior vehicle car, it could apply a similar type of preset that we just created, and ours doesn't have to worry about that. They've already created or done a LOD for that type of asset, do something similar, and maybe they can work off of that. Or not, just do a fresh tool. And finally, the last part of the tool was export. This needed to be as easy as possible, save into the right directory, compress everything on top of each other, and make sure that the actual source asset is, again, laid out properly so it has its mesh hierarchy, it has its parent, and has all its information with the proper naming convention. So if we look at a breakdown of how I created this tool, the initial state of this tool looked like this. There were nodes all over the place. I was trying to figure out what works, what doesn't work, and try and find out the fundamental of the tool. How can I actually use the polyreduce node in different ways and get a better outcome? So the first step was create the actual tool. Then let's create a cleaned HDA of it, of a single version of the tool that if you instance this in, it can choose which setup does it want to go. And each switch just has an if statement saying, is it this poly count? Is it this area? Is it whatever setup you want? Choose the setup. And then we can switch along the way, ensuring that it tries to go the most ideal setup as it creates. Finally, we just have to finalize. We take entire blocks from the LOD tool. So the compile loop and the two for loops are taken directly from the LOD tool. We can just add our HDA in as one of those nodes along the way. And we can start stacking more and more HDAs to do different types of cleanup. So as you go down, you can see I have 3 different setups here. And this switch node right here says, if you are this specific type of prop, go this way. If you are this ambient occlusion or this AO or curvature or anything, go this way. And this type of setup this way. So within each of these nodes is its own HDA that checks for specific type of setup. And this was the moment that I discovered exactly how to actually use the polyreduce in a more effective way. And I'll share this with you today. If we nest the polyreduce inside of a for loop and then a compile loop and have nothing else in there, and then use the for loop and iterate over different types of methods. So if we create connectivity by objects of specific sizes, so if you have all of your objects that are this size and below as one piece, do this polyreduce. Or if you have this specific area or this connectivity or this curvature, do different types of, for example, connectivity, so we can connect them in different ways. So you almost lump together different parts of objects that have very similar attribute setups. So this needs to be viewed. If we start with the keyboard and just throw down a straight polyreduce, this is the outcome you get. You completely decimate the keys and they lose the connection of actually what their pieces look like. However, you need those pieces to know exactly, don't destroy them if they can. And you can't just set a tolerance and say, the tolerance hasn't been broken, don't polyreduce farther from there. So the setup I chose was, if the objects are below this area size, if they are below 2 centimeters, lump them together as one connectivity attribute. So the keys all get the attribute 1. The keyboard piece is a much bigger area, gets attribute for connectivity 2. And then the desk 3, and so on. So each set of objects with similar matching attributes get lumped into that setup for the for loop. This ended up not destroying my keyboard. Everything looks identical of exactly how I intended to. And we can reduce it from, say, 100 polygons to 10. And it forced the poly count to not destroy itself, because it would actually check, is that possible? If that's not possible, do this setup and do it less aggressive. The next thing I needed to look at was multi-parming, of course. I needed the user to say, I want 1 lot, I want 10 lots, I want 100, and making sure all of the actual settings they use can work along the way. they don't just apply to LOD1, for example. So you can just string cat the channel name, or for example, alpha channel or vertex color, and then the iteration. So it always works with whatever multi-parameter it is. The next step was naming convention. I needed to ensure that if we are going from one naming convention from one project to another, that we are able to force or standardize that naming convention. So we can use regex, hey, it's not matching your naming convention or whatever setup you want, and force it into the new naming convention. And this allowed you to, as you create your LOD, ensure that you have standardized the naming convention. The final step was failsafes. Using the switch node, and if you go to the actual documentation, you'll find these two lines here, is the error and warning. If the switch determines that the path has an error or warning, go this specific direction. And this allowed me to ensure that the tool never would fail. If the polyreduce was too aggressive, I would often force it to debug a error or a warning, depending on how bad it actually destroyed the mesh. So it was almost mesh analysis in that sense. If it detected it was warning or an error, it would do a different type of layout. And this ensured that my tool was never too aggressive or completely destroyed the mesh. Now in Houdini 18, you actually have the switch if geometry node. And this is super useful because instead of using a switch, now you can just have your actual if checks or any type of expression checks inside of a single node, and it can choose which way to go. The final thing I wanted to look at for the logic was FBX exporting. There's a tool called Hammer Tools, and you can find the GitHub by this link online, and it allows you to determine if the pieces are names. For example, if we have LOD1 named LOD1, LOD2, LOD2, and for example, and so on, the tool can actually just sort by name. When you hit export, will create its own subnet, version out a object merge of each object. So if we take this mic, we can object merge, this is one piece and this is one piece, and inside of the actual mesh hierarchy it will export them together. Instead of when you just have one single mesh combined, it will export them as one big chunk. So this looked like save to disk, you can just split by your name, and you have your output file. This allowed you to just say this is exactly where the output file is located, split them by your specific naming convention, and go on from there. The final thing I wanted to look at was PDG and prop destruction. We wanted a system that allowed us to pre-fracture a lot of our geometry and work with it in different ways. So if you start with a picture frame on the wall, you know that you want the start and end point. So you can run an RBD sim and just fracture it. So this sims someone shooting at it or knifing it, and you could have different setups for how they actually interact with the prop. From there, you could take a suitcase, for example, and the same exact methodology goes. If you shoot the suitcase, you want the pieces to scatter down on the floor and have a specific layout. You also want the piece that's left behind, so you actually have a base of this is where the original prop was located, so you can see in the center of the scene that we have the bottom of the suitcase. So you will always have flat scatter of rubble around this center piece. This creates a few problems being pre-fractured, as if you shoot something that's hanging off of a table, now you may have some of the meshes that are actually hanging off the table. So you wanted the artist to actually draw a custom layout after the RBD sim. So I worked on a setup just that you say this is a specific layout, or you could draw a curve or a shape or anything, and after you RBD sim, force your objects and blend between the RBD sim and the forced into this packed shape. So this allowed us to sim any type of destruction. So you could break a glass that was near a table edge, and then artists after the fact could draw a shape, fit it within this space on the table, and would push the pieces that were hanging off back onto the table. There are two methods to this also, because you could in-game just raycast down and ensure that it actually has ground below it, but we want to do this as a before that actually happens. So an artist could even generate through PDG, I want 5 different versions that they could choose from, and then have a random version of it. This allows you to just do prefract geometry, very automated, very quickly, and then you can do your raycast later on to ensure that you, again, don't hang off of something. The final step is creating the actual positions in the UVs. So we use UV3, and we can have all of your mesh pieces and have their specific point location respected in the scene. So a visual effects artist later on can just alert between their original center point and into their new positions and have the nice visual effects transition. The final step was PDG and actually automating all this. I needed to ensure that I could take a file pattern or a location of all of my props or FBXs, run through my ROP geometry or my HDA processor, and then actually fracture all of them, create all their LODs, and automate this entire process. I just had to specify this is exactly where my props are located, give me pre-fractured and a destroyed state for every single one, and give me 5 different versions of every single fracture. For the future, these are some of the things I want to look at, and some of the things I think would be really useful for integrating in the pipelines. Houdini and PDG plus Shotgun and Jira will really simplify the process of creating hundreds and thousands of assets at a AAA level. Now, I've taken these images from a Houdini presentation earlier this year, but we have an exact same process internally. If we have all of our assets in an asset bank, for example in Shotgun, you could go through the entire extraction process from a game, grab all of their renders, all of their objects, and now you have their exact props inside of the asset bank. From there, you could process them. So we could run through our LOD creation, you could run through our normal cleanup or any other tool that we have as an HDA, and finally upload to Shotgun, or for us, Jira. So you could start with your actual process of extracting an asset, creating its LOD, creating all of the tools, and then simply uploading to its associated Jira task. And this allows you to automate all of the process and really simplify it. However, moving forward, we really need to look at a USD-based pipeline. A lot of the challenges I faced was because each tool I looked at did not have standardized anything. The materials were set up in different ways, the objects were placed in different ways, anything was different between softwares. So if we use a data structure that's actually standardized, we know that between projects that we take the same type of data structure and we standardize that, so we could have our materials set up as the USD format. So when you change between all of your DCCs, so if we go from Anvil or Snowdrop or any other internal engine, and we go to Houdini, for example, we can have the exact same file format. No one has to reconfigure the data in a different way to make it supported between other tools. And finally, Houdini centralized. This is important because if we use Houdini as the basis, it becomes project agnostic. If a project suddenly says we're not using this tool or this type of software anymore, using Houdini as the fundamental translation between softwares allows you to run, one, your HDAs, but also it always ensures that you just have to manage the data coming in and you are able to set up your custom setup for data coming out. So if you have Unity, Unreal, any type of software coming in, you can then export into another software. And Houdini is the fundamental transition because you just have to have, again, standardized structure and it will always work with the same tools. So if you take away anything from today's talk, the first thing is you first need to make a tool once. You need to make it work just by itself. It doesn't need to be an HDA, doesn't need to be an encapsulated asset. You need the first version of the tool working. So for me, the LOD tool was, I just need to be able to create a LOD that's better than Simply Gone or the internal Houdini tool. The next was create an HDA out of it. Make it a Houdini digital asset that can be a module that is implemented into your wider toolset. So if it is a normal tool cleanup, or if it is a LOD tool creator or an extraction tool, make it an HDA that can just slot into a greater pipeline. And finally, batch it. You want all of your HDAs to be able to work inside of PDG so that you can run a HDA processor and run through all of your objects and have them just follow through the pipeline of PDG and go through automated without you having to interfere along the way. A lot of the key learning material I think you should look at, again, is the side effects documentation. There's a lot of questions I see on the Houdini Discord that could be fixed just by going to the documentation. The next was, for me, learning Python. If you go to the second link, there's a lot of really key learnings are actually how do you work with Python inside of Houdini. The third link is Tokru, and this is where you can learn Vex, and some of the small Vex functions I use are taken actually directly from a site. And fourth, you can go to the gameartinstitute.vertexschool.com and look at my Houdini training that will be coming out soon. Now again, we're hiring, and so please go to the Ubisoft Montreal website and check out our careers website and look at some of the key Houdini positions we have coming up. Thank you very much, and enjoy my procedural poutine. Feel free to follow me on my Twitter